All right, so my name's Anthony. I'll be presenting object detection using YOLOv3. So if you guys haven't already, go to that link down there. It should take you to a page that looks like this. Go ahead and download the two items to your desktop or wherever. And then you just do that, click there, and then hit download. Yeah, so it might take a while to download, so I'll go back to the presentation real quick. All right, so computer vision. What is it used for? And what does it do? Computer vision is basically a technique that people have developed for computers to see, which is kind of interesting because if you think about it, computers only know numbers, and then so we need to figure out a way to convert images or videos to numbers. Computer vision is used in many places, such as autonomous vehicles, image captioning and tagging, and then object detection or optical character recognition, which is basically when you take a picture of text, it can transform it into a actual text that you can mess around with. The way that it does this is through something called a convolutional neural network, or CNN. Basically, CNNs it's like a neural network that has slightly different properties. It takes in an image as a number. So as you can see here, there's a picture of a dog. It would be represented by a 3D matrix. It would be the length and the height of the image as well as the RGB values, so the red, green, blue. And then once it takes that in, it performs what's called a convolution, which is basically matrix dot product. So as you can see here, there's a filter of a 3x3 grid, and it goes across the whole image and then multiplies it and gives you a smaller new matrix. The reason why they do this is to detect edges and different patterns inside the image. It also reduces the dimensions of your input so that it's easier for it's more easily, you can compute the next step easier. And then after you put it through a convolution layer, you apply a pooling layer, there's two different types of pooling layers, max pooling layer and average pooling. Max is basically where it just takes the max of that grid and then averages taking the average of that grid. Max pooling is better for reducing noise because the smaller values get dropped. And then this also reduces the number of features, which decreases the computational power as well, so you can train your models faster. In a CNN, they basically have this convolution layer and pooling layer. They do that multiple times in order to detect different features within the image. So the earlier layers will detect stuff such as edges and patterns, whereas later layers can detect features of the object you're trying to detect. So if there was a dog, it would be able to detect an eye, a nose, a mouth, or an ear. So after you go through all of the different convolutional layers and pooling layers, you want to flatten them out into a image that we feed into basically a regular neural network for classification. And from this, as you can see down here, it's a fully connected network. It'll take this 3D array and then squish it into a 1D array, and then you feed it through the neural network, and your network will learn to predict which object it is from that input here. So image classification, basically you take in an image and the goal is for your model to tell you what image that was. So if there was a picture of a dog, it can output dog, right? Convolutional neural networks can only detect stuff that has been trained on. You can't detect grass or something in this picture. The main difference between object detection and image classification is location. So in image classification, it'll just tell you there's a dog in the picture, but it won't tell you where it is. Object detection will tell you exactly where the dog is in the image. So imagine self-driving cars. This would be really useful to tell where the actual car is in the image, because if you don't know where it is, you're probably going to run into it. So object detection works in two different ways. One is called a two-stage neural network. it basically identifies regions that can have some object, and then it classifies the object in those regions that it thinks there is an object. But then the algorithm we're going to be looking at is YOLOv3. It's a single-stage network, or a single-stage network. Pretty much what it does is it creates like boxes around like the whole image, and then it'll be like different dimensions based on like the objects it's trained to detect, and then based on that, it'll filter the class out by like how certain it is there's an object in there, and then you'll get something like that. So it starts off with kind of boxes throughout the whole image, and then gets more precise. So YOLOv3 is pretty much one of the fastest prediction models out there right now. It has a decently high accuracy as well. It's not as accurate as the two-stage models, but if you want something that has like really fast detection speeds, then YOLOv3 is like one of the top ones. As you can see here, like in this graph, the inference time, YOLOv3 is the star one. The inference time is far behind like these two other object detection models, but like the accuracy is still fairly high. Does anybody have any questions so far on what object detection is, convolutional neural networks? No?
I had a quick question.
Go for it.
Earlier in a couple slides, you showed us like the CNN kind of pipeline
Yes.
for this, and we have a softmax layer at the end
Mm-hmm.
to detect a single item. I was wondering, is there like a layer that can detect multiple items at once?
Yes, that's a good question. It can detect multiple items at once. You can set like a threshold so that if it's predictions like past a certain point, then it'll show up in the.
So all of these wouldn't need to add up to one?
Actually, I think what this is doing is it's predicting it for each of the boxes, like this. Like these smaller boxes, it's predicting to see if it's actually in there. I could be wrong, don't quote me on that. I don't exactly know, but that's what I believe it's doing. So like it would run the classifier on each of the smaller boxes. But I feel like that's not right either. But yeah, I'll have to get back to you on that. I don't know for sure. All right, so if everybody's good, everybody downloaded the two files, we can get started on the code. The code's basically just going to show you guys how to run YOLO on Colab, because YOLO takes like a good amount of like hardware to run, and most of us don't have a couple $100 to throw on a GPU. So we'll be using Google Colab. One thing is though, they might kick you off if you use it too much. Like you'll just get a slower priority in the queue. Do you need the link? No. Okay. Well, anyway. So yeah, now that you've downloaded the files, show in folder. Okay. I think it's this one. Go ahead and extract the files. Was that the right one? Yes, okay. And then once you've extracted the files, you can go ahead and upload it to your Google Drive. So Google Drive, sign in, go to new file upload, and then give me a sec. Where's this? Downloads. Go ahead and upload those to the drive. It should take a few minutes. Shouldn't take too long though. If anybody's having trouble with that, let me. What's up?
I can just put it in.
Yeah, let me come to you now. Okay, while this zip file is uploading, that's like the main folder. You can open up YOLO on Colab.ipynotebook. Just double click it, and then it should say open in Google Collaboratory. Oh, I didn't update that. Great. Yeah, so we pretty much have to wait till the zip file is done uploading before we can actually start on any of the code. Actually, we can mount our drive. So pretty much what this is doing is mounting your Google Drive to your Google Colab notebook.
Send it to me, dude.
Thanks.
Yeah. 018813.
Cool. Go ahead and allow, copy the sign-in code, go back to Colab, paste it in. And you should have mounted it, if everything worked correctly. Is anybody still waiting on their darknet.zip to upload?
Yeah.
Okay. I'll give it a minute.
Yeah, it's done. It's a big file.
It's about a gig, yeah.
Yeah, that's pretty chunky.
Good thing I removed all the data. I had about like 8 gigs of pictures on there for my other thing.
Oh my gosh, no worries.
Oh, and if for those that don't have the link, all right, give me a minute. That's the link.
Yeah, it's also on the boards.
Oh yeah, board. Andrew, do you have your plug? You got about 2 minutes before it dies. Where is this thing? Don't die on me. Cool. All right, does everybody have their zip file uploaded? Raise your hand if you don't have your zip file uploaded. All right, give you guys a minute. Yeah. Upload it like directly to the My Drive folder, because if not, you're gonna have to change some paths and. All right. So if you guys haven't mounted the drive, go ahead and mount it. You can run the cell by using Shift Enter or Control Enter. It'll give you this link, and then just click on the link, sign into your drive, copy the authorization code, and then paste it back in here. Does anybody need help with that? No? Cool. I'm gonna start running this stuff. So pretty much what I'm doing here is going into the drive and then unzipping the file that we just loaded. This should be fairly quick. All right, how many of you guys were able to unzip? Show of hands, 1, 2, 3. Ah, close enough. All right. So now we're gonna go into the darknet folder using the cd command. The next thing we're gonna install is called DOS to Unix. It's basically if you made a text file in Windows or any file in Windows, it adds like an extra character when you move it to Linux. So DOS to Unix fixes that. So just go ahead and install that. And this isn't installing on your local machine. This is installing on Google's VM. So yeah. Next thing we need to do is there's some software that you need to download if you want to use the GPU. You could go ahead and just run these 2 lines, and then it will install the software for you. Anybody have any questions or lost? Cool. Once you do that, you're gonna want to. You guys might not need to do this to make clean, but go ahead and do it anyway. And then you're gonna run the make file to compile the code. And then you should get this ugly thing. It's just warning, so it's okay. It's not errors. This might take a minute or two to compile. Anybody else need help with anything? Good? Good? Good. Why is that? Let me copy. Okay, when your program finishes compiling, you can go down to the test part. There's different images inside of the folder. You could check them out if you want. Darken it. So the first one we're going to look at is a picture of a dog right here. Dog, there's a bike, and there's a car back there. We're going to see if the pre-trained model could detect it. So go ahead and run that next line. It should look something like this. It's loading, it's creating like the architecture, and then it will load in the weights. And then after it's done, it'll run the model to detect the different objects inside the image you just upload. And then you should be able to see it within the darknet folder. It should be called predictions.jpg. Yeah, so as you can see here, let's see if I can expand this. So it's able to detect the dog, the bike, and the truck. You guys can also test it out on different images. There's a lot more in the data folder. You guys can run it on like kite.jpg, see what it detects on there. Stuff like that. Were you guys able to run the model? Cool. How many of you guys were not able to run the model? Okay, what's the issue? Okay. For which one? Give me a sec. Is anybody else having any issues? Okay. So that was through the pre-trained weights. So if you want to train your own model, you would have to basically change some stuff up. Currently in my data.zip folder, it has pictures of water bottles. So we're going to try to detect that. We won't be able to finish training the model today because it will take a couple hours. But this is pretty much all the code you would need to train it. So what we're going to do is copy the data files from our drive to the VM. So scroll down until you see create train test split.txt files. You can just copy that over and then unzip that file inside the VM. And then go ahead and, oops. Go back into the darknet folder, and then you're going to run the script that basically splits the data into a testing set and a training set. And then you just input the directory, which would be content/data. And then like these outputs are here are from files where I didn't have a So pretty much the way that YOLO has the labels is it has an image, and then it has that same image name but .txt, and that txt file contains where the box is or where the image is within that file. And then those are the ones I didn't have labels for, so it skipped over them. Next thing we're going to do is we can probably start training. You're going to run the DOS to Unix stuff on those 3 files just because those are the files that you would usually modify if you're changing up how many classes you were doing or the data types. And then you're going to go ahead and run that next line and it should start training. You'll see it starts to load up the weights once again, creates the architecture, and then loads up the weights. And then every time you want to add a new object to your model, you would have to retrain from the darknet 53 weights. Yeah, and that's pretty much the training. You would let this run for several hours or until it's done with its iterations. Yeah, that's pretty much it. Anybody have any questions? Go for it.
Train for new objects, does it like preserve the previous detection capabilities?
No. So like, okay, so in here, basically you put the weight, this is going to be your weights. If you've trained it for a while and you want to continue training, you can upload like a dot. So this, give me a sec. This line of code gives you different weights, and the model will save the weights periodically. I have it set to save every 500 iterations, I believe. So after it hits the 500 iterations, it should output a .weights folder or a file. You can just input or change this to whatever weights you want it to be, and then it will continue training from there. But if you want to, so like let's say you've trained a model and it detects like 5 different objects, you wanted to add a new object, you would have to retrain again. So you won't retrain using those weights, you would have to retrain using this darknet 53 conv.74.
What is the
This is like pre-weights. Or like these are, I don't know how to explain it. It's kind of like weights you would use to start your training for new models.
instead of just having random weights starting there?
Yeah, I think this is like pre-trained, so it's like it's easier to get your model to learn new things from here than completely random weights. Did you have a question too? Yeah.
Okay, quick question, but I don't know if it's like related, but so I've had some experience with like object detection using like SIFT, like surf, and all those words,
Mhm.
different kind of methods. And so like, how does YOLO play into that? Does it like utilize all of them, or is it just completely separate?
I'm not really familiar with those, but like the way that, what are those? Are those like different?
Yeah, they're like algorithms to like detect edges and things like that,
Mhm.
detect objects.
So the way that YOLO works is, let me see. I don't know the specifics too well, but the way that it works is it'll basically create like different boxes around, like throughout the whole image, and then determine whether or not something inside of that box fits a certain class that it knows. And then from there, it will pretty much like add on the other boxes to like create like the whole image.
Okay. I think the way the other ones work is that it has like feature matching, so it finds like individual features that are like close to each other, and they match the features with like the ones from another picture.
Yeah, I think that's kind of how it works.
Yeah, okay.
Yes.
The main that you had sent for this workshop, you had a GIF which showed like real time in video.
Oh yeah, that works too. I haven't gone around to that. I've just been using it for images. But there's the guy's website where you can pretty much look for more stuff. It's yeah, darknet. You can learn how to set up your model using a webcam. I believe that's, yeah, here, real-time detection on webcam. I'm pretty sure you can also feed in like or video files as well. Just like the stuff that I was using it for was just images, so I didn't really look into the video side.
Is darknet the name of the neural network? Or?
Darknet is, yeah, it's like, so the algorithm is YOLOv3. The people who created the algorithm created Darknet, which is like the C++ or C version of like the model. There's other versions that you can run. It's a Alexi AB or something like that. He has stuff that you can run on Windows. This thing, you have to train it in a Linux environment. Or I guess you can do it in Windows too, but it's a bit more work. Yeah.
You know how fast one like forward passes through the darknet?
Oh yeah. Let me scroll up. It was able to predict it in 1.34 seconds, which is weird because I've gotten it down to like 0.0 something seconds. I don't know why it's doing 1.3 right now, but yeah. I think it's able to detect up to like a couple hundred frames a second. So it's pretty quick. Yeah, I don't exactly remember.
So if you were to put like a object detector onto a drone, do you know what type of network you'd use? Like
For
darknet or maybe encryption or something like that?
if you're putting it on a drone, okay, so if you're running the drone like off a Raspberry Pi or something or an Arduino, like there's not much computing power on there, so you'd probably use something called a single shot detector or SSD. That works slightly different from this, but it's like a lighter weight model, I believe. This would pretty much require like a GPU or you to send the footage to like a server or something, and the server would send it back.
You could use a cloud function too. So if you have something sitting on a like Raspberry Pi, like your little webcam or whatever, and it has like a Wi-Fi, you could just send all the pictures to a remote host or a cloud somewhere that you've hosted this model, and they would give you results offline.
Assuming your internet's fast enough.
Yeah, unless you yeah.
Just stick an Ethernet cable up and just have it fly.
Perfect, yeah.
All right, anybody else have questions or how it works? Anybody stuck on something? No? Cool. All right, that's pretty much the whole workshop. If you guys have any questions, feel free to come up and ask me or anybody else about any other stuff. But yeah, thanks for coming.